Hi, Dr. Caps. Travis White-Velez back again this week with another advanced interactive concept presentation. This week we're going to be talking about heat capacity and how that relates to thermochemistry. For this week's presentation, you will need a few things. It will be a lighter or a heat source. In my case, I'm going to be utilizing a grow lighter, and some balloons, as well as a water source and an air source. Stay tuned, and I will be back to perform the experiment. And then after the experiment, I will explain why what happens during the experiment happens and how that relates to thermochemistry. Hi, Professor. I am back. I have gathered my supplies. So I have my grow lighter or heat source. I have my balloons, and I have my water source. I'm going to start by taking 2 balloons. I'm going to fill one with air. Tie that off. Set that to the side. I'm going to fill another with water. And then I'm going to blow some air into it. And then tie that off also. Set that to the side. For the first balloon, I will utilize the one that is filled with just air, and we will see how long it takes for this to react or explode, or we'll see. And now the one with water. Okay, so we see that one didn't pop. Now let's put it where there's no water but just air. See how long that lasts now. All right. So now that I've completed the experiment, stay tuned and I'll return with what just happened and how it relates to thermochemistry as well as heat distribution. Okay, so now that that experiment is complete, I will explain why what happened. So in the case of the balloon, we had air inside one of the balloons and we had water inside of the other. Heat capacity is defined as the amount of heat input that it takes to raise the temperature by 1 degree Celsius. So a common, comparison is if you take a metal chair, set that metal chair in the sun, that metal chair will get significantly hotter in a shorter period of time than if you were to take, by gram weight, that same amount of water and set it in the sun. At some point, the water does heat up as heat energy goes into the water, but it's more evenly distributed, so it's not as hot to the touch. In the case of the balloon, the outside of the balloon absorbs the heat until it eventually breaks apart. With the water inside of the balloon, the heat is more distributed away from the heat source, so more heat can stay on the balloon for a longer period of time, or better way of putting it, the balloon can take on more heat with water than it could with air. Air does not distribute heat very well, or it does not distribute heat as well as water. And that's also a reason that water is so vital to, survival on Earth. I hope I explained what heat capacity is and why it's so important. And I hope this lab did a good job of helping you understand it if, my verbal definition of it did not. Thank you for your time and have a good night. Also, just before I go, I forgot to do a quick safety disclaimer that I should have put at the beginning of the video, but I will just add in now. If there are any kids that happen to see this lab, I would recommend asking your mom and dad, or mom or dad, for help. Never operate flammable, tools without adult supervision. Also wear your safety goggles. Thank you for your time. Enjoy.